Hello guys, welcome back to my channel, Maison African Motives. Still working on engineering. In this platform, we shall be focusing on mathematics N4, the question paper which was written in November 16th of November 2022. That's an X paper. So we just want to see how we are supposed to answer this typical question paper from the request of us that we wanted me to revise this question paper. So I'm going to do that in this platform. So without wasting much of our time, let us quickly rush through the paper. First things, guys, make sure that you understand the instructions that you're given. Show all intermediate steps. Make sure that you simplify wherever possible your answers to 3 decimal places, unless it is indicated otherwise in that question paper. But the rest of the instructions, they are clear. Okay, so the first question that was to prove we're given 20 marks on trigonometry. So the first part was just to prove an identity. So I'm just going to simplify so that we can see what exactly was supposed to be done on this one. So I can even write this question aside. Okay, let me just write this side here. I think it can help us. All right, so I'm just going to rewrite this question here. That's 1.1. So we were given 1 plus sine y, that is 1 plus sine y over 1 minus sine y. In this case, minus 1 minus sine y all over 1 plus sine of y. And this must give us 4 tan y sec y. Okay, let me check again. But that was the sec y there. Okay, so that's it, 4 tan y sec y. So that is what we are given. And if you have to cross-check, 5 marks for that. Okay, so let us see, quickly rush through the question. The first thing that we can actually do here was to take the side that we are supposed to work with. So in this case, I'm going to focus on the left-hand side. Okay, so on the left-hand side, what is happening? We are subtracting. So definitely we have to find the LCM of these two denominators, which is 1 plus sine y and 1 minus sine y. So in this case, our LCM is going to be 1 minus sine of y into 1 plus sine of y, like that. Okay, so as we know, guys, in a normal subtraction or addition, we have to divide our LCM divide by this denominator here. So you can see this and this will cancel. You remain with 1 plus sine y. So we are going to have 1 plus sine of y, which is being multiplied to 1 plus sine of y again. Okay, taking note that we are subtracting, so we're supposed to subtract the same thing. We divide just like what we did in the previous part. This 1 plus sine y here and 1 plus sine y will cancel, which means we are going to remain with 1 minus sine of y. So 1 minus sine of y into 1 minus sine of y, which is in the numerator there. So this is what you're having, but take note there's a negative. So that means this negative is going to affect whatever that you're going to get from these two. Okay, so the next part, that is the expansion. As we can see there, we are supposed to expand the brackets so that we can simplify. So here we've got 1 and 1. So that's 1 times 1 here, which is a 1. So we are going to have 1. Then we move on again, 1 times sine of y here, which is sine y. So this is going to be sine of y. We move again to sine, that's sine times 1, which is sine y. So we've got sine y there. Then we move again, that's sine y times sine y here, which is sine squared. So this is going to be sine squared y. Okay, let's see what you're going to have. That's a minus. Take note of the bracket. Whatever that you're going to obtain here, you have to expand by the negative. So it's 1 times 1, which is a 1. We move on, 1 times minus sine y, that's minus sine y. Then we move on to minus sine y times 1, which is minus sine y. So that's minus sine y. Then we have got minus sine y and minus sine y. So negative and negative, that's a positive. So we're going to have positive sine squared y, like that. Okay, not forgetting the LCM or LCD, we have to write it as it is, which is 1 minus sine y into 1 plus sine of y. Okay, So that was the stage that we are going to obtain from there. We can simplify like terms as usual. So that means we can expand whatever, collecting like terms, expand brackets. Okay, so here we are going to remain with a 1. So let me indicate here that's a 1. Sine plus sine, this is same as 1 plus 1, which is 2. So this is 1y. This is 1 plus 1, which is 2. So you're going to have 2 sine of y. Okay, plus sine y squared. So that's sine squared y. Okay, so here we can simplify. Then after that, we expand by negative. So this is 1. Minus 1 here, minus 1. So minus 1, that's minus 2. So we've got minus 2 sine of y plus sine squared y. But this has to be expanded by the negative here. So it's negative times 1, which is negative 1. Negative times negative 2, that's a positive. So we've got positive 2 sine of y. Then we've got negative times positive here, which is a negative sine squared 1. Okay, everything over the LCD, which is our LCM, which is everything over 1 minus sine of y into 1 plus sine of y. Okay, there we can collect like terms. That is, if we got like terms, then we can do that. So we've got 1 minus 1, that's a 0 there. Sine squared minus sine squared, that's a 0 there. So we are left with 2 plus 2, which is 4 sine y. So we are going to have 4 sine y, everything over 1 minus sine of y into 1 plus sine of y. This is where most of you guys had a challenge on this part on how to simplify here. Okay, guys, remember your identities from your difference of two squares. We understand that a squared minus b squared is equal to a minus b into a plus b. So if we've got two brackets which are the same, but the only difference is on minus and plus there, it means it was from a squared minus b squared. So that means this part here can be written as 4 sine of y over this part here. We've got a minus and a plus. These two are the same. So a squared minus b squared, that's 1 squared minus sine y squared. So this is going to give us 1 minus sine squared y. Or you can expand the brackets, you are going to obtain the same thing as what I'm writing here. All right, then we also understand from our identities, there is this part that cos squared y plus sine squared y is equal to 1. So what made us to obtain 1 minus sine y squared? It means we have to transpose this to the other side. So cos squared y is equal to 1 minus sine squared y. So 1 minus sine squared is actually equal to cos squared. So that means we were going to have this expression as 4 sine of y over cos squared. This whole part is equal to cos squared. So it was going to be equal to cos squared y. All right, of which we know that cos squared simply means we've got two of them. Cos squared y simply means we've got cos y times cos y. So we can actually separate that way so that we can obtain in the way that we are given there. So this was going to be 4 sine of y, everything over cos y times cos y, like that. Okay, so here we've got 4, which is going to remain as it is. Now let's get back to our identities. Sine over cos. Whenever we've got sine over cos, that's a tan. So this is going to give us tan y. Whenever we've got 1, because this is now 1 over cos. 1 over cos, remember it's sec. So this was going to give us sec y, which is the same thing as what we had on the right-hand side. So this is actually the same as what we had on the right-hand side. So that is what we're supposed to do in order for you to prove this identity. I think these steps are actually enough for you to obtain the 5 marks that you had. So it was a matter of adding, subtracting first the fractions that you're given. After subtracting, you simplify, applying your identities, and so forth. But I think it's actually from there. So that's it, guys. Trigonometry. Please make sure that you understand the questions that you're given. Okay, so without wasting much time, let's move on to 1.2. So 1.2 was for us to simplify. So I'm just going to remove this part so that we can simplify. Okay, so simplify the following There it was just a matter of adding the two. So I'm just going to rewrite this part here. That's 1.2. So we are given tan theta over sec theta minus 1, then plus tan theta, everything over sec theta plus 1. So it had the same concept like what we had before, but we can just simplify just like what we did in the previous part on subtracting, but this time you're adding. So you're going to obtain the LCM of these two, which is sec theta minus 1. So we've got sec theta minus 1, sec theta plus 1. Okay, so let's add, just like what we did, guys. If you divide your LCD by sec theta minus 1, we're going to remain with sec theta plus 1, which is multiplied to tan theta. So we're going to have tan theta times sec theta plus 1, plus here we move on sec, and sec will cancel, you remain with sec theta minus 1. So it's going to be tan theta into sec theta minus 1. Okay, that means we can actually expand brackets so that we can collect like terms. Okay, so let's see what you're going to have. Tan times sec, that is going to give us tan theta sec theta. Tan times 1, so it is going to give us plus tan theta. Tan times sec, it is going to give us tan theta sec theta. Tan times minus 1, that's minus tan theta. Okay, everything over. Remember what we did last time from our difference of two squares there, where we had something of a squared minus b squared. A squared minus b. Remember, I told you it's a minus b into a plus b, which is the same scenario that we have on this part. So this is just going to be sec squared minus 1 squared, which is 1, of which you can expand brackets. Yes, you are going to obtain the same thing. So this was going to give us sec squared theta minus 1 from the difference of two squares. Okay, let's simplify. Collecting like terms, tan theta and tan theta was going to cancel out. Then we are remaining with 1 tan theta sec theta plus 1 tan theta sec theta. So it's 1 plus 1, which is 2. So we are going to obtain 2 tan theta sec theta. These are like terms, so you can add them. Okay, everything over sec squared theta minus 1. Let's get back to our identities. We understand that 1 plus tan squared theta gives us sec squared theta. So here we've got sec squared theta minus 1. It means we just transpose this to the other side. So we remain with tan squared theta is equal to sec squared theta minus 1. So whenever we are seeing this sec squared theta, we are actually referring to tan squared theta. So that actually means this part was going to be written as 2 tan theta sec theta over tan squared theta. But knowing that tan squared theta, there are two of them. So we can cancel 1 here, tan and tan, which means we are going to remain with tan theta here. So this part was or can be written as 2 sec theta over tan theta. Okay, we all understand that whenever we've got a sec is just same as okay, let me write it down. Sec theta is actually from 1 over cos theta. Okay, so this part actually means we're going to write this as 2 over cos theta. For us to have 2 sec theta, it was 2 over cos theta. That's 2 sec theta. So it is going to be 2 over cos theta divided by tan theta. Okay, knowing that tan theta is equal to sine theta over cos theta. That's tan theta there. So we can actually simplify this further by writing as 2 over cos theta, which is, this part was just the same as sine theta over cos theta from tan. But if you are dividing, remember that you're going to introduce multiplication. And the moment you introduce multiplication, you invert the second fraction. So it was going to be cos over sine theta. So this was going to be cos theta over sine theta. Okay, the cos and the cos was going to cancel out. That means we are going to remain with 2 over sine theta, knowing that 1 over sine is a cosec. So 2 over sine theta is 2 cosec theta. That was the simplest answer that we could have written. So there's so many ways actually that you can work out. If you have any other method, feel free to comment on the comment section so that I will know how actually attempted this question, or how did you manage to simplify this question, so that we can see if it is actually proper way of simplifying. So that was it on 1.2. Let's move on to the other part of the question, which is 1.3. So on 1.3, we're given a certain consideration. Let me just remove this part here. We're given that if cos theta is equivalent to 3 over 5, and cos A, is equal to 3 over 5, and this A that we are talking about ranges from 0 to 90 degrees, that is, we are talking about the first quadrant. Without using a calculator, calculate the value of cosec over 1 plus cos A. Okay, so this was the question. So the first thing is for us to actually indicate the region where we are supposed to have this cos A, because we're given that cos of A is equal to 3 over 5. And we actually know that from our identities, from our SOHCAHTOA, that's SOHCAHTOA there, cos is actually equivalent to adjacent over hypotenuse. And from 0 to 90, I referred to as the first quadrant. So this was going to be in the first quadrant. You're going to have a triangle like this, where this is your A. So according to this A, we've got the adjacent, which is this part, the hypotenuse, which is this one. So definitely you're supposed to calculate the third side using Pythagoras theorem. We know that h squared is equal to a squared plus b squared. That's the hypotenuse squared. 5 squared is equal to 3 squared plus the other side that we do not know. 25 is equal to 9 plus b squared. 25 minus 9, that's 16, which is equal to b squared. Then we've got the square root of both sides, which was going to be plus or minus 4. But here we are referring to a positive side. So our b, which is the other side, was going to be 4. So this side that we see here, that's a 4. Okay, as if that's not, because this is just simplifying for us to have the other side of the triangle, so that at least we can simplify the expression that we are given. Okay, so let's simplify. Cosec of A, we actually have cosec of A over 1 plus cos of A. What is this cosec of A? Let's start by cosec. We said cosec actually means 1 over sine. That is where we've got our cosec, 1 over sine of A. So we need 1 over sine of A, which is the same thing as 1 over. Let's check our sine. We said sine is from SOHCAHTOA. Sine is opposite over hypotenuse. So we've got opposite over the hypotenuse, which is 4 over 5. Okay, which was going to give us 1 over, guys, that's the inverse, which is going to give us 5 over 4. We just invert this fraction. So this is our cosec A. That's our cosec A. So now let's simplify here. We are going to substitute cosec A. We obtained 5 over 4. Okay, so this was going to be like this. Cosec of A, it's 5 over 4. So it was going to be 5 over 4 over 1 plus cos A. So it's 1 plus, already cos of A is given here. Cos of A is 3 over 5. So you're going to add 3 over 5. Okay, so you can add 3 over 5 is going to give us 8 over 5. So you're going to be 5 over 4 plus, because this one here is same as 5 over 5. So it's 5 over 5 plus 3 over 5. So 5 plus 3 is 8 over 5. So this was going to give you 8 over 5. Okay, so that's it. We can simplify. We're dividing. Remember, if you're dividing, you multiply. So it's 5 over 4. This way C is supposed to be like this, so that you can understand what I'm saying. So it's this fraction divide by this fraction. So the moment you are to multiply, you are going to invert the second fraction. So the second fraction is going to be 5 over 8. So this was going to be 5 over 8. Okay, 5 times 5, that is 25 over 4 times 8, which is 32. So that was the answer, 25 over 32. If we are to simplify it properly, we're going to obtain 25 over 32. Okay, so that was it for the simplification. We move on to 1.4. So let me just remove this part a little bit. Okay, so let's check 1.4. Determine 1 over sec minus 15 without using a calculator. Okay, so that is 1 over sec minus 15. Where do we have this? Okay, let's write it down. So this is 1.4. 1 over sec minus 15 degrees. Okay, so the first thing is, where do we have sec? That's the first thing, sec. Okay, so sec is equivalent to what? We know that sec theta is actually equivalent to 1 over cos of theta. So this part that we see here is same as 1 over. Then we have got sec minus 15, which is 1 over cos minus 15 degrees, like that. Okay, 1 over, I told you guys, whenever you've got a condition like this, 1 over A over B like this, it simply means B over A. So 1 over this fraction simply means we are going to obtain cos minus 15 over 1, which is cos minus 15 degrees. So that is what we're going to have, of which we know that from our negative angles, let's take from our negative, we know that negative angles are taken this way. So minus 15 is somewhere here. That's where we have minus 15 degrees. And we have all students take calculus, whatever that you're going to have. But this quadrant for cos is always a positive. So it simply means cos minus 15 degrees is equal to cos 15 degrees, because the quadrant that we have, cos, is a positive. So the question that we are asked here, this question here was simply supposed to be asked like this: simplify cos 15 degrees. That was supposed to be the question. Anyways, they just want to strain you in exam. I don't know why, but that's it. Let's simplify now. So how do we simplify cos 15? Because that is our question now. How do we simplify cos 15? We know from our special angles, we've got 45 degrees, we've got 30 degrees, we've got 60 degrees, we've got 90 degrees. So we can play around the angle so that we can obtain 15. From 45 and 30, we can obtain 15. That's 45 degrees minus 30 degrees. This one, it gives us 15. So that means we are going to apply our special angles, knowing that cos 45 minus 30 is same as cos A minus B, of which we know that cos A minus B is supposed to be cos of A, cos of B, plus sine of A, sine of B. So this part here was going to be the same. So it's AB, so it's going to be cos 45 degrees, cos 30 degrees, plus sine A, which is sine 45 degrees, sine 30 degrees. Okay, so let's apply our special angles. At this part, we can actually have our special angles, which is, okay, let's just have a sketch here. Just going to indicate just the angles, the triangles from your maths N2 there. We have got 45 degrees, 1 square root of 2. We have got something of this nature, 30 degrees. This is going to be 60 degrees, 30 degrees. We have got 1, 2, and square root of 3. Okay, that's square root of 3 here. Okay, so these are our special angles that we have. And from this part, we understand that cos 45 degrees is going to be adjacent of our hypotenuse. So it's 1 over square root of 2, which is same as square root of 2 over 2. So we've got square root of 2 over 2 times cos 30 here, that's adjacent over hypotenuse. So it's square root of 3 over 2. So it's going to be square root of 3 over 2 plus sine 45. Remember that cos 45 and sine 45 are the same. So we've got square root of 2 over 2 times sine 30. Sine 30 is opposite over hypotenuse, which is 1 over 2. So we can simplify from our side, square root of 2 times square root of 3, that's square root of 6. You multiply 2 times 3 over 2 times 2, that's 4, plus square root of 2 plus 1 times 1, that's square root of 2 over 4, of which you can leave your answer like this, or you can just add together. You simplify on top, square root of 6 plus square root of 2, everything over 4. Yes, you can just leave your answer like that, or you can simplify further if you want. You can factor out square root of 2, but that was another way you can do, but which is not even proper there. Okay, so that was the simplification, guys, of 1 over sec minus 15. Sec 1 over sec minus 15 is the same as cos 15. So cos 15 can be simplified in this manner. which is the one that is going to give us this result. And that is what you're supposed to do. Okay, that is it. 1.5, we are now asked to solve the following equation. That's a trig equation. All right, from minus 180 up to 180 degrees. Take note of the interval that you're given. Your theta is supposed to be taken from minus 180 degrees up to 180 degrees. Okay, so let's just write our equation first. This is 1.5. All right, so we got something like this, 1.5. Okay, I'm just going to write it was 2 cos 2 theta plus cos 2 theta minus 1, which was equal to 0. So that was the equation that we are being given to solve from minus 180 to 180 degrees. Okay. As we can see, we have got double angle identities here for cos 2 theta, cos 2 theta, of which we know that cos 2 theta can actually give us something. It depends with how you wanted your answer to be. You want it to be in terms of sine or in terms of cos, because in terms of cos, it's going to give us 2 cos squared theta minus 1. In terms of sine, it was going to be 1 minus 2 sine squared theta. So you're supposed to choose from this, not this one. This one was not going to be cos squared minus sine squared because we've got two identities which are different. So this one was totally out. So you're supposed to choose between these two. So as for me, I'm just going to choose this first one, but the answers, we are supposed to obtain the same answers. Okay, so that's it. Cos 2 theta is same as 2 cos squared theta minus 1. So that means here we've got cos 2 theta here on this part. Okay, let me just indicate properly. Here we've got cos 2 theta, but take note is being multiplied by 2, which is already there. So it is going to be 2 times whatever that we have for cos 2 theta, which is 2 cos squared theta minus 1. Okay, plus cos 2 theta again, which is 2 cos squared theta minus 1. And there's a minus 1, which is already there, which is equal to 0. Okay, so that was it. We're supposed to expand 2 times 2. That's 4 cos squared theta. 2 times minus 1, that's minus 2. Plus 2 cos squared theta. Minus 1, that's minus 2 is equal to 0. Okay, let's collect like terms. We have got cos squared and cos squared there. So you can add the 2. 4 plus 2, that's 6. So we've got 6 cos squared theta. Minus 2, that's minus 4, which is equal to 0. So we can solve our equation. 6 cos squared theta minus 4, we can transpose minus 4 to the other side of the equation is going to be a plus 4. You can divide by 6 both sides, by 6 both sides. So that means we're going to have something of this nature. Cos squared theta is equal to 4 over 6, of which 4 over 6 is same as 2 over 3. We can just use your calculator there. 4 over 6, which is 2 over 3. So it was going to be 2 over 3. Okay, so to obtain cos theta, there is a squared. So to remove this squared, remember that you have introduced square root both sides. So if I introduce square root, that means cos theta is equal to plus or minus the square root of, okay, let's write it this way, the square root of 2 over 3. So here we've got two possible values for cos theta. It can be a plus or it can be a minus. So taking now into consideration the interval that we are given, or the range from minus 180 up to 180 degrees, where do we have this cos being a negative and being also a positive? Okay, so that's it. We are going to have two things here. The first one, the cos theta, which is the positive square root of 2 over 3, and the other one, which is equivalent to minus the square root of 2 over 3. So with all these, it doesn't matter everything. We are supposed to find the reference angle that we are supposed to use, which is actually the same as the critical values. So the reference angle is taken from arc cos. So theta is equal to arc cos the square root of 2 over 3. Okay, so arc cos simply means shift cos from your calculator. That's shift cos the square root of 2 over 3. So that's the square root of 2 over 3. Close the bracket. Let's see what you're going to have. All right, so that is 35.26. So that one is actually just a reference angle, something like that. So it's 35,264, something like that. 25, is 35,26, something like that. Okay, so that was your theta, actually, like a reference angle. So now let's start with the positive, then we go to the negative. So from the positive, we all understand, all students take calculus, cos is positive here and also in this quadrant. Okay, so this is where our cos is in positive. Okay, so there are two ways that we are going to have in this. In the first quadrant, it is going to remain as it is, which is 35,26 degrees. In this quadrant, from this angle, it is going to be minus 35,26. Remember, your interval is from minus 180 to 180, which means we can also include negative angles. This one was not going to work from this to the other part, from this here to the boss. It's already more than 180, so we are not going to use that one. We're going to take the negative one. Okay, so that means here our theta, therefore our theta was going to be equal to 35,26 degrees minus 35,26 degrees. Okay, that is where our cos is a positive. We move on to the other one, where this cos is now a negative. So cos is a negative in this quadrant of sine. Here cos is a negative, and here cos is also a negative. But this one is not going to work because it's already above 180. So our answer was going to be taken from sine, which is this value here. So remember that this in the second quadrant, it's 180 minus the reference angle. So this here was going to be 180 minus the reference angle of 35,26 degrees. Okay, so let's see. 180 minus 35,26 degrees, which was going to give us something like 144,74. So we have got 144,74 degrees. Okay, so we can actually just cross-check with the negative. Okay, square root. Let's just prove the last one. The square root of 2/3 is something like 0.816, something like that, or negative. Okay, so I just want to prove if it was a negative 144,74, was it going to give us the same answer, negative 8,1? So which means also the negative was going to be part of the answer here. Okay, so and negative 144,74 degrees. Okay, so these were the values of theta that we were going to have from minus 180 up to 180. Okay, so that was it, guys, to solve the trig equation that we're given. So it was a matter of applying identity. So like I said, we could have used this one for 1 minus 2 sine squared theta. So I wanted to prove this one if you're obtaining the same answers. If not, then we shall see this question on another video or another platform. Question 2, let's see what we had. Solve for x. The first equation was for us to solve for x. So this one, it is direct. Anyways, that's 2.1. Okay, so this was a direct equation. 3 to the exponent of 2x minus 1. So let me write it down. That's 2x minus 1, which is equivalent to ln 8. Guys, remember that whenever you're solving these exponents, introduce logarithms, that is ln. So you just introduce ln both sides. This is ln, and this is also ln. So remember that the moment you introduce ln, you're going to drop this exponent. So it was going to be 2x minus 1 ln 3, which is going to be ln 8. So this is what you're supposed to have. So here we can divide by ln 3 both sides, by ln 3 both sides, so that this can cancel. Okay, so we are going to have something like 2x minus 1 is equal to ln 8 over ln 3. Okay, so we can transpose the minus 1 to the other side of the equation, which is going to be a plus 1. So that means 2x is equal to ln 8 over ln 3 plus 1. Okay, whatever that you're going to obtain here, we have to divide by 2. So we can simplify first, or we can just divide by 2 is fine. So 2x is equal to, let's simplify this part and see what we're supposed to obtain. So this is actually like this. Put a fraction. So it's ln, then ln 8. Ln 8, close the bracket, close the first bracket. Okay, so you have to close twice there, over ln 3. Okay, like that. Close this bracket again. So we are going to obtain 0.663, something like that, 0.663, something like that. Divide by 2, divide by 2. So therefore, our x was going to be what? So from this part that we have, we just have to divide by 2. So it's 0.333, like that. So that is what we're going to actually have. Okay, let's just cross-check something. I want to cross-check something here. Ln 8. Okay, close this bracket, divide by ln 3. We are supposed to have a +1 here because I didn't add this one. Okay, so it is 1 comma, not 0 comma, but this is 1 comma. Okay, let me do this. Here it's 1 comma, here not 0. I hope someone saw that part. Okay, so that is 1 comma. So whatever that you get from this 1 comma, we divide by 2, which is 0.8331, something like that, 0.8331. So that was the value of x from the equation that we asked to solve. 2.1. Okay, 2.2, make M to be the subject of the formula. Okay, so this was actually an impossible question. So here we've got M, here we've got M here and there. So I don't know how this is supposed to be this one or this one. So it's actually because if you are to use your, if you are actually using, if you are typing, let's say you want to type 3 to the exponent of 2. It won't be 3 to the exponent of 2 like this. You won't see it like that. The 2 is going to be small. So this M and this M are the same. But this is actually impossible for us to solve. So this one was actually impossible. All right, unless they wanted to have a capital letter M, and so that this can be a capital letter M, that way maybe it was going to work, not this one. So this was actually impossible on 2.3, field marks for that one. Okay, 2.31, draw the graph of y is equal to cosec x. So we need the graph of cosec x from minus 180 up to 180. Okay, this one is, it actually looks like this, cosec x. Okay, I can even have it here. That's 2.31. 2.31. So if got the graph of y is equal to cosec x. These graphs, guys, you're supposed to know them, how to sketch actually. Okay, so that's a sketch for cosec x. We have got 0 degrees. Let me have it here, 0 degrees, 90 degrees, up to 180. So this is 180. So at 180, it's an asymptote there at 180. We have got minus 90 degrees, minus 180 degrees. At minus 180, it's an asymptote there. Also, this one, it's an asymptote, this one. Okay, so it actually looks like this. This one, guys, you're supposed to know this graph. Okay, so it's just something of this nature. Okay, so that's it. And we've got another one on the positive region like that. So that's something on top, something like that. Okay, so that's it. If it is actually a cosec, remember cosec is 1 over sine, 1 over sine. So it's going to be 1 over sine, 1 divided by sine 90. 1 divided by sine 90 is what? That's a 1. So this one is not supposed to be on the ground. It's supposed to be at least above, somewhere there. At least somewhere there, something like that. Okay, so this actually corresponds to 1, and this actually corresponds here to -1. Okay, so this is the graph that we have. It does not reach the y-axis, 180 or minus 180. Those are the asymptotes. So that was 2.31. And 2.32, what are the asymptotes of the function y is equal to? So the asymptotes, we can see this graph cannot reach this part, 2.32, minus 180. So we've got minus 180 at 0 degrees and also at 180 degrees. Those were the asymptotes. So that was it. 2.4, draw the graph of minus x squared. Okay, let me just save it here. I'm just going to put it down here, 2.41. we have got minus x squared is equal to y over 4. So this part, to just make y to be the subject, cross multiply. If I just cross multiply here, y is equal to minus 4x squared. So that's it. We know that the graph of minus x squared, it actually like, it's a sketch, this one, guys. So that's a 0 here. So this one was going to look the same way the graph of minus x squared look like. So it was going to be something like this. Okay, that's the graph passing through 0 here and something like that. So that is y is equal to minus 4x squared. So this one we're supposed to just make y to be the subject. Okay, so from this, is this graph a function or is a relation? This is a function, guys. As you can see, it's 1:1. So it's a function. And is this graph continuous or is discontinuous? This is a continuous function. As you can see, it's a continuous function. So that was it. So guys, 20 marks just for that. 20 marks, 20 marks, 20 marks, just like this, guys. So these are some of the typical questions that you can take advantage of in exam. Okay, the integration part on 3.1. So as usual, guys, whenever you are integrating, make sure that you actually simplify first everything in a proper manner. In this case, everything was actually fine, so you can just even try to work it aside. Remember, on integration, we add, this is minus 2x to the exponent of minus 2, so you're supposed to add 1, so it's going to be 2x to the exponent of minus 2 plus 1 over minus 2 plus 1. So that's it. 2x to the exponent of minus 1 over minus 2 plus 1, that's minus 1. Minus 2 plus 1, that's minus 1. So it's going to be 2 divided by minus 1, which is minus 2. So this was going to give us minus 2x to the exponent of minus 1. The same thing here, but on this one, okay, we can just apply the same thing because this is a negative 1. So if we add now, it is going to give us a which does not actually work in a proper manner, just like what we know. So 3x to the exponent of minus 1 is same as 3 over x, of which you know that the integral of 1 over x, it's ln x. So this was going to give us 3 ln x. So it's 3 ln of x. 2 by 5. Okay, from our integral, we understand that when there is something of this nature here, the integral of ka to the exponent of x is going to be ka to the exponent of x over ln a. But I want you to see something. Actually here, if there is a number, let's say this is bx, this is going to be b ln a. So from this part here, this is your a, this 2 is your a. So the answer was supposed to be 2, which is the k, so it's 2 by 5 to the exponent, which is a to the exponent of bx. Okay, so if this is a b here, so this was going to be 5 to the exponent of 2x over b ln a. So our b is 2, so it's 2 ln a, which is this 5. So it's 2 ln 5. As you can see, the 2 and the 2 can cancel. So you're going to have 5 to the exponent of 2x over ln 5. That is what we're going to have there, 5 to the exponent of 2x over ln 5. Okay, so that was going to be plus 5 to the exponent of 2x over ln 5. Okay, then we move on to tan. Guys, we know that tan gives us sec squared. This is the integral. So we can even cross-check, but its tan is going to be ln sec. That one is actually ln sec. Okay, but you can cross-check here. Is there tan, the integral of tan is actually that one. Okay, tan here, it's ln sec. So that is what we had. So this is ln sec. Okay, so we are going to have ln sec x, but there is a 4 here, so it's going to be 4 ln sec x. So that's it. Plus 3 sec squared. Remember, sec squared was taken from tan, so this was going to give us 3 tan x plus 3 tan x and plus the constant of integration. So we've got 6 marks just for that. Okay, so that was the integral part, integrating. Okay, 3.2, we've got the integral of, but this time we've got limits that we have. So this is pi over x, which was actually a mistake there on that limit. I don't know, they wanted to have it as pi over 3 or pi over 5. or pi over 2, we do not know. It's not supposed to be over x. That was an error there. Okay, so anyways, let's see what we're supposed to do. 3.2, the integral of, we're given pi over x. This is a 0 here. We've got 2 cos 2x dx. We know that when we are integrating cos, it gives us a sign. If we are given something like this, the integral of cos bx, it is going to be 1 over b sine bx plus c, the constant of integration. Remember that. So this we've got a 2, which is already there. So it was going to be 2 over 2, then it's sine 2x. So take note on that part that of the 2 and the 2 there. Okay, then we've got our limits, which is in this case are the ones which are wrong. So it was going to be pi over x 0 there, of which this is actually wrong. So let's see what we are going to have if we've got this pi over x, which is actually wrong. So 2 and 2 is going to cancel, which is okay, 2 and 2 cancelled there. So it's going to be sine 2x, the limits pi over x 0. So if it was a normal value like pi over 2, pi over 3, we're going to substitute here just like usual. So, but in this case, let's see what is going to happen. It is going to be sine 2x, which is pi over x like that, minus sine 2 times 0, which is a 0 there. 2 times 0, guys, that's a 0 there. So sine 0 is actually a 0. So you're going to have sine 2 pi over x. So that is what they wanted, or I don't know. It was actually a typing error, but if we had a value, then we can simplify this. Because there is x, we can't simplify. So you're going to leave your answer just like that. Okay, so that was it on 3.2 integration, guys. Make sure that you apply your integration properly. I think that's what we had. 3.3, we are now given to sketch the graph of y is equal to x squared plus 4 and clearly indicate the area include. Okay, let's see this part. Okay, included between this and x is equal to 0. Okay, the graph of y is equal to x squared plus 4. We are supposed to know the graph of y is equal to, guys, N4 mathematics, you are supposed to know how to sketch from your mathematics N3. So make sure, guys, you understand so that you do not waste time in exam trying to sketch these graphs. It's supposed to be a normal thing that you're supposed to have before you enter exam, to know how to sketch the graphs. Okay, anyways, let's not waste time. It's already something that was written. Okay, 3.31. Y is equal to x squared plus 4. Okay, so this graph actually looks like this. From you take it from the sketch of y is equal to x squared. Remember, the graph of y is equal to x squared is like it passes through 0. So when there is a plus 4, you just add 0 plus 4, so it's going to pass at 4. So this one is going to look the same. It's going to have the same shape, but it is passing at 4 now. So like this. So this is the sketch that we can have. This is the y-axis. And at this point, that's where we have 4. That's our x-axis. Okay, so after sketching this graph of y is equal to x squared plus 4, it is not enough. We are also told that we are supposed to indicate the area included between this graph, the x-axis, the line x is equal to 0, x is equal to 2. Okay, so the first thing is between this graph and the x-axis, which means that for this region between, and x is equal to 0. This is the line. The y-axis is our x is equal to 0. So we are referring to the y-axis, and x is equal to 2, maybe somewhere there. We can just say this is where we've got x is equal to 2. So this is the area that we are referring to, where this is 2 and this is 0. And that is it. So that was a sketch, just a sketch. So this is where we're going to have our area. Then from there, we are now told to calculate the magnitude of the indicated area with the aid of integration. We know that we can obtain area from our integral calculus. How? How so? We know that area is simply the integral of f of x, 3.32 area with respect to x is the integral of f of x, whatever that you have with respect to x with the limits a and b. So that means we're going to just integrate this expression that you are given. The limits is from 0 to 2. So that's 0 to 2. What are we integrating? F of x, which is x squared plus 4. So I've got x squared plus 4 with respect to x. That is integration for you guys. To calculate area simply means integrate. That's it. So if you know your integration, then it was going to be easier because there's just integrating. Remember, you have to add 1. So it's going to be x to the exponent of 3 over 3 plus, this is a constant, so it's going to be x with the limits, which is 2 and 0. So this is the part that I was saying from the previous question. If we have got normal values like this, just substitute your values into the expression. The first part is 2, so it's 2 to the exponent of 3 over 3 plus 4 times 2. This is what we have. The other part minus, that's a 0 here, 0, any number, that's a 0 plus a 0 there. So that one was going to be direct 0 there. Okay, so that's it. From your calculator, you can actually simplify 2 to the exponent of 3, that's 8. So we've got 8 over 3 plus 4 times 2, which is 8 minus 0. Okay, so that was the area. So we can simplify 8 over 3. Whatever that we get, we add 8, which was going to be 30, 2 over 3. So we've got 32 over 3 square units. This is area, or you can write it as a mixed fraction, which was going to be 10 and 2/3. So we've got 10 and 2/3 square units, or you can write it as a decimal. I don't know which one was best for you. 10,6, 6, 6, and 7. So it was going to be 10,667 square units. So any of this was going to be your answer from that. Okay, so that was 3.32. Now 3.4, we are given to integrate. So this one, we can even integrate it here. We are supposed to separate here. As you can see, I've got everything over x. So we can write it as the integral of x squared over x minus x over x. So to remove this x, we divide each and every term by x. Okay, so that was it with respect to x, which is the integral of x into x squared, that is x minus x, and x is going to cancel. We get minus 1 with respect to x. Let's integrate and see the integral of x. We add 1 plus 1, that's 2. So it's going to be x squared over 2 minus 1 is a constant, so it's x. Don't forget the constant of integration. Okay, so that is what you're supposed to obtain from this integral, just like that, guys. And how many marks for that? 2 marks, that's why. Okay, that's why. Okay, we move on to question 4, which was on derivatives. Remember, guys, now they are separating these questions, integration, derivatives separately, like that. Okay, determine the following limit. So there we were given a certain limit. Remember, guys, from your limits, I told you, the first thing is to check with the limit that you are given if it is possible. Because sometimes you don't need to work, you just have to substitute and see if the answer is fine. So here, if you substitute 2, it was going to be 2 to the exponent of 3 minus 8 over 2 minus 2. So this is 0 over 0, which is actually impossible. So what are we supposed to do? Okay, let's take this aside, since it is impossible for us to have 0 in the denominator. Okay, I want you to see something here. I want you to have, this is x cubed. Okay, I'm just going to rewrite it down, it's fine. That's 4.1. We've got limit as x approaches to 2 of x cubed minus 8 over, it was x minus 2. Okay, remember, there is the most important part of factorization that we have of cubic expressions. A cubed minus b cubed is equal to a minus b into a squared plus ab plus b squared. This factorization, you are supposed to know it, guys. Why is this so? Because if we are to cross-check, this is x cubed, this is 8. Remember, 8 is same as 2 to the exponent of 3. So that was actually the same as writing as x cubed minus 2 to the exponent of 2, 2 to the exponent of 3, like that. So we have our a and our b. So from this simplification, it was supposed to be a minus b, which is x minus 2. So we've got x minus 2 into a squared. So this is x, which is our a, which is x squared. So it's x squared plus ab. Ab is x times 2, x, a, and b. So it's x times 2, which is 2x, plus b squared. Your b is 2. So 2 squared is 4. So this is what you're supposed to have after factorizing. So that means this limit was supposed to be written as the limit as x approaches to 2 of x minus 2 into x squared plus 2x plus 4, everything over x minus 2, which is the one that we have in the denominator. As you can see, x minus 2 was going to cancel out. So we are left with the limit as x is approaching to 2 of x squared. All right, so this was supposed to be of x squared plus 2x plus 4. Now we can try the limit. Let's substitute. If x approaches to 2, what are we going to have at the end? It was going to be 2 squared plus 2 times 2 plus 4. That's 2 squared, which is 4 plus 4 plus 4. 4 plus 4 plus 4, that's 12, isn't it? 4 times 3, that's 12. Okay, so this was the limit that we're going to have at the end. So our answer was just going to be a normal number, which is a 12. Okay, 4.2, differentiate with respect to x. Y is equal to log 5x with aid of a function You are told the method to use, which is function of function or chain rule. Show all intermediary steps and the substitutions that you do. Okay, so that was the question that we're given. Okay, y is equal to log 5x. Let me just remove this part here so that we can do it. So that was 4.2. Y is equivalent to log 5x. Remember, guys, we're dealing with a log. If the base is not given, it automatically means you are in base of 10. Yes, you could have find this answer direct. It's fine. It's fine. We know that if you're given a log, y is equal to log f of x in base a, like that, the derivative, which is dy dx, is supposed to be f prime. That is the function f prime x over f of x ln the base that you're given. That is the derivative of a log. But in this case, we are told to use chain rule or functional function. So remember, from functional function, you're supposed to introduce another function into this expression. So we can just let u be equal to 5x. So I'm going to let my u be equal to 5x. Therefore, I'm now having another expression of y, which is equal, in place of log 5x, it is now log u in base of 10. So that is what I'm having now. Okay. Let's simplify. We know that function of function, it simply states that dy dx is equal to dy du times du dx. That's our function of function. So this is the formula that we're supposed to use later on. So it simply means we need to find du dx from here, du dx. So du dx is going to be 5, guys. This is the 5, just a constant there. Then we have got dy du, the derivative of y with respect to u. We said log is the first derivative. The derivative of u, it's 1 over f of x. Our f of x in this case, it's f of u, which is u ln a, which is the base. In this case, our base is 10. So it's ln 10. Okay, so this is what we're supposed to obtain in terms of u. Then now we can substitute into the formula for dy dx. We said dy dx is going to be dy du, dy du, that's 1 over u ln 10, times du dx, which is 5. Okay, so if I multiply, this is same as 5 over 1. So it's 5 times 1, which is 5 over 1 times u ln 10 is going to be u ln 10. But this is not enough because this is the derivative of y with respect to x. But cross-checking on our answer, there is a u on our answer here. So we are supposed to get back to the u that we have here. Our u is equal to 5x. So you're supposed to substitute 5x into your final answer. So this was going to be 5 over 5x ln of 10. And that is not enough because we can divide 5 and 5 here, that's 1. So we are going to have 1 over x ln 10. So that was the answer for this one. So I think everything was clear. Just everything was clear, just hope so. That is what we're supposed to have at the end. So you can just cross-check with any other method and prove if truly we are going to obtain the same thing. Okay, in 4.3, that was actually a quotient. Apply quotient rule to find the derivative. Okay, so we are going to apply our quotient rule. So this is y is equal to cos x over ln x. So that's 4.3. Okay, 4.3 y is equivalent to cos of x over ln x. Remember that if you are using quotient rule, the numerator is your ux and this is your vx. So it simply means we have got our ux as cos x and our vx as ln x. And we know that there is a need for us to find the derivative of u. So if we differentiate cos, it gives us negative sine x. The derivative of ln, remember ln is 1 over x. And everything once done is just a matter of substituting into the formula. Okay, that is dy dx is equal to vx by the first derivative of ux minus ux by the first derivative of vx over vx squared. So if you have forgotten, guys, go back to the formula sheet. The formula is already given. I want you to cross-check something here. Let's see what we have. This is the formula, dy dx, the one that you are given here, the quotient rule. That's your quotient rule here. So you just have to apply your formula properly. The order here does not matter on these two, the arrangement on this, but we are supposed to have in that orderly manner. Yeah, that's something like that. Okay, so anyways, let's substitute into the formula and see what we're supposed to have at the end so that we can simplify this. So it's just a matter of substituting now the answers. Okay, so that's dy dx, sorry, dy dx is equal to vx. Our vx is ln x, so it's going to be ln of x by the first derivative of u. The first derivative of u is negative sine x, so this is negative sine x minus ux, our ux is cos, so it was going to be cos x by the first derivative of v, which is 1 over x. Okay, everything over vx squared, of which our vx is ln. So it was going to be ln x, but we have to square this. Okay, so that was it. Yes, we can simplify, but as you can see, we actually have nothing there. So you can just write maybe as dx, dy dx is equal to negative. So you can just write as negative ln x sine x negative cos x over x and all over ln squared x. Yes, we can just write it like that, but still this way is fine, just to leave it like that. Okay, so that was it, guys. On the derivatives, applying the quotient rule from, so you're supposed to know all the rules: product rule, quotient rule, and also chain rule, which is function of a function. Okay, now on 4.4, differentiate with respect to x. So we know that whenever we are dealing with derivatives, all we need is to work it separately. So that's 4.4. Cot is actually fine. Remember the derivative of cot, it gives us negative cosec squared x. But there is a negative which is already there. So negative and negative, that's a positive. So that was dy dx was going to be positive half. So there's already a half which is there. So it's positive half cosec squared x. Okay, we move on to the square root of cos x. Remember the derivative of cos, it's negative sine x. So negative and negative was going to give you a positive. So it's positive square root of 2 sine x. Then we move on to log. I explained the log before. I told you whenever you're dealing with a log, the derivative is supposed to be f prime over f of x ln the base. So the base here, we are in base 10. The base is not given, so that means you're in base 10. So the first derivative, we are just going to have this as a 7. We've got 7x. So this is your f of x, which is 7x. So the derivative of 7x is 7. So it was going to be 7 over f of x. Your f of x is 7x. So it was going to be 7x ln the base, which is ln 10. But as we can see here, 7 and 7 will cancel. That is 1 over. But remember the 1 over 3, which was already there. So it is going to be plus 1 over 3. We write this as it is, which is 1 over x ln 10. So we've got 1 over x ln 10 from that. Okay, then we move on to tan. Remember tan, guys, it gives us sec squared, but there's a 2 here, so this 2, you multiply it. Okay, sorry for that. This tan that we have does not have x. There is no x here, there's a theta. So it is a constant now. Remember, if there is no x, we have, because this is with respect to x, and here we do not have x. So it means this is a constant, just like a normal number, just like tan 90 or tan 45, which is what is, so it's a normal number. So whenever you differentiate a constant, we get a 0. So that was going to be a 0 there. Okay, so that one, take note, there's no x there. Okay, 4.5. Calculate the coordinates of the turning point. Okay, let me just remove this part so that we can work it here. Calculate the coordinates of the turning points of y is equal to x cubed minus 9x. Distinguish them. So that is what is the question is actually asking us to. So whenever you're asked to calculate the coordinates of the turning points, remember this is the derivative. So already we are given as y. So at the turning point, we know that dy dx is supposed to be equal to 0. If it was f of x, then the first derivative is supposed just like that. So we have got y, which is equal to x cubed minus 9x. So let us find dy dx first. Dy dx is going to give us what? If we drop this exponent, it's going to be 3x. We subtract 1, that's 3x squared minus 9x is going to give us a negative 9. Okay, but this is supposed to be equal to 0 at the turning point. So that means 3x squared minus 9 is equal to 0. So you can solve this as a normal equation. 3x squared is equal to 9, transpose to the other side, divide by 3, both sides. So x squared is equal to 3. So to find x, introduce the square root both sides. So your x was going to be plus or minus the square root of 3. Knowing that square root of any number is a plus or minus. But in this case, we are supposed to have the coordinates. So these are the points that you're supposed to actually have. So what you are going to have is the first turning point where x is equal to square root of 3, or the other one where x is equal to minus square root of 3. So let's have the first turning point. We substitute the value of x, which is square root of 3. Remember, it's a point which is made up of x and y. So here we just have to substitute into the normal equation, that is x cubed minus 9x. So our x is square root of 3. So it's going to be square root of 3. All right, to the exponent, let's see, square root of 3 to the exponent of 3 minus 9x. So it's minus 9 square root of 3. We are going to obtain minus 6 square root of 3. Or we obtain the other turning point, which is the second turning point, when x is minus square root of 3. What are we going to have? So normally, as you can see, this was square root of 3, it gave us a negative. So this one is going to give us a positive 6 square root of 3. So these are the two turning points that we have from the derivative. But now we are further told to distinguish between minimum and maximum turning points with the aid of the second derivative. These 2 points, we want to know which one is the maximum turning point and which one is the minimum turning point by using the second derivative. So how do we apply the second derivative? We know that the second derivative is supposed to be the second derivative with respect to x. If it is greater than 0 like that, it means that's a minimum turning point. Then if the second derivative with respect to x is less than 0, then that means it's a maximum turning point. So this is what you're supposed to prove. So it simply means we were supposed to actually determine the second derivative from the first derivative that we have, because already the first derivative is there. dy dx is 3x squared minus 9. Okay, so let's continue from there. From our 3x squared minus 9, I can just even write it here, guys. Don't mind this part that is written here. Remember, your dy dx was 3x squared minus 9. So the second derivative with respect to x is going to be, we drop the x, going to be 6x minus 0. That's 6x. So now you're supposed to compare from this second derivative if you are to substitute. So let's work with the first turning point, okay? So working with the first turning point, which is the first turning point was the square root of 3 minus 6 square root of 3. So we are going to substitute the value of x here. Our x is square root of 3. So if we were to substitute square root of 3, as we can see, 6 times square root of 3, that's 6 square root of 3, which is a positive, which is this one. It's greater than 0. Greater than 0 means a positive. So this is actually a positive. So that means it's a minimum turning point. So the first turning point, that was our minimum turning point, okay? We move on to the second turning point. Our second turning point in this case was minus square root of 3, 6 square root of 3. So if you are to substitute the value of x, which is minus square root of 3, it is going to give you minus 6 square root of 3, which is a negative. Less than 0 here means we are dealing with a negative. So since it is a negative, therefore it's a maximum turning point. So this one was a maximum turning point. So that was it on the derivatives. We can actually obtain 20 marks for that. So these are the typical questions that they can ask on derivatives. So everything was actually fine on this question on derivative. Let's see the other part, which is question 5. So question number 5, it was actually from our complex numbers, a mix of complex numbers, and the application of the Cramer's rule from our simultaneous equation. So the first equation was for us to determine or to use Cramer's rule to determine the value of x1 and x2. So the first thing is the order. Remember, Cramer's rule, we are supposed to use it when we have constants on one side of the equation. So here there was a need for you to transpose minus 4x2 to the left-hand side so that it can be a positive. So let us just write it here. So this is 5.1. So it was going to be 2x1 plus 4x2, which is equal to 4. Okay, the other equation is fine. We just have to rewrite as it is 3x1 plus 7x2 is equal to 6. All right, so to find x1, remember Cramer's rule, to find x1 is actually the determinant that we are going to have for x1 over the determinant of constants. To find x2, we'd find the determinant with respect to x2 over the determinant of constants because we want to calculate both. Okay, so let's start with the determinant with respect to x1. We know that we have to close this part with x here and substitute with constant, which is 4, 6. So it is going to be 4, 6, then 4 and 7 remain as they are. Okay, we do the same thing, determinant with respect to x2. We close that part where we have got x2 here, we substitute with constants. So this part is going to remain as it is, which is 2, 3. But for 4 and 7, now you replace the constants, which is 4, 6. Then the last one is the determinant with respect to constants, which means the constants, we just have to take this part and this part as it is, 2, 3, 4, 7. So guys, remember your determinant, that's the product of the major diagonal minus minor diagonal, which is 4 times 7 minus 4 times 6. So that is the determinant with respect to x. So, okay, let me just write it here. Determinant with respect to x1. So just multiplication, here we can just do it aside. 4 times 7, that's 7 times 4 minus 4 times 6, that's 4 by 6, which is a 4. So this is 4 here. Okay, that's a 4. Then determinant with respect to x2 is the same, the product of the major diagonal, which is 2 and 6 minus 4 and 3. Okay, so that's 2 by 6. Okay, so let's see, 2 by 6, 2 by 6 minus 4 by 3, 4 by 3 like that, which is a 0. So this one was going to give us a straight 0 there. All right, sorry, that's a straight 0 there. Okay, then we move on to D, which is the last one. So it's the same thing, the product of 2 and 7 minus 4 and 3. Okay, so that's it. Okay, sorry for that. Let's see. Let's see what you're going to have. Okay. Sorry for that. Okay, sorry for that. I just wanted to minimize the calculator, then it minimized the board. Okay, anyways, we have got 2 by 7. In this case, that's 2 by 7 minus 4 and 3. So that's minus 4 by 3, 4 times 3, which is going to give us something like 2. So this was going to be a 2 here. Okay, so we have our expressions. Now we can find the answers. Remember, we indicated that x1 is determinant of x1 over determinant of constants. So x1 is determinant of x1, which is 4, over determinant of constants, which is 2. So 4 over 2, that's 2. We move on to x2, determinant of x2, which is 0, over determinant of constants, which is 2. So that's a 0 there. So x1 was going to be 2, x2 was going to be equal to 0. So that was it for 5.1. 5.2, write down and evaluate the minor of element 7. So the minor, remember guys, the minor, we just have to close the row and the column where there is 7. So we are left with 5, 3, 2, and minus 3. Then we calculate the determinant of that, which is 5 and minus 3. And we subtract, just like what we did from the previous question, guys. I think this one is now clear. Okay, so we can just simplify that. 5 times negative 3. 5 times negative 3 minus 3 times 2. So that's 3 times 2, which is 21, negative 21. So that is the determinant, which is the minor. So it's negative 21. Okay. Then after that, 5.22, write down and evaluate the cofactor of element 7. So the cofactor is a signed minor. Remember, a cofactor is a signed minor, which means we have to multiply by the sign which correspond. Remember, we can just apply our sign plus, minus, plus. So we are supposed to multiply by negative. So this was going to be equal to negative times negative 21, which is positive 21. So that was the core factor. Okay, 5.3, the impedance of Z, the impedance Z of a circuit is given as, that is the expression by this part where Z1 is equal to this, Z2, Z3, determine the value of Z. Okay, so that was simply a mere substitution that was supposed to take place for Z. Okay, so we've got our Z, which is, okay, let me write this, is 5.3. So Z is equivalent to Z1 minus Z2 by Z3 over Z2 plus Z3. So let's start by substituting Z1. Z1 is equivalent to 2 plus J5. So that was 2 plus J5. 2 plus J5 minus, here we have to multiply Z2 by Z3. So Z2, that's 2 plus J2. 2 plus J2. So we have got 2 plus J2 times Z3. Our Z3, which is 2 plus J4. So that's 2 plus J4. So the question is for you to simplify 2 plus J4. So Z2 plus Z3, this time we add 2 plus J2 plus 2 plus J4. So let's simplify and see what we are going to obtain at the end. Okay, so the first part, just leave it as it is. 2 plus J5, just leave it as it is, minus. On the top, we can expand brackets. That's 2 times 2. All right, 2 times 2, that's 4. Okay, we move on to 2 times J4, which is J8. So we've got J8. Then J2 times 2, that's J2, that's J4. So it's going to be J4. Okay, then we move on to this part, J2 times J4. Remember that J squared is equal to minus 1. So it is going to be negative 8. 2 times 4, that's 8, and j squared, that's a negative. Okay, the same thing, we can simplify here. 2 plus 2, that's 4. j2 plus j4, that's j6. Okay, is it not enough? We have to simplify again. 2 plus j5 minus the fraction, you can collect like terms here. That's 4 minus 8. 4 minus 8 is actually minus 4. Plus 8 plus 4, that's j12. Everything over 4 plus j6. Okay, so from this part now, it was for you to simplify further. How can we simplify? Here we are having a fraction. So we know that whenever we are having a fraction, we are supposed to multiply by the complex conjugate of the denominator by introducing a negative so that we can simplify the given fraction. So here we are supposed to have something of this nature. Let's just write it here so that it can be proper. Okay, so our z was going to be 2 plus j5 minus multiply by the complex conjugate, both the numerator and the denominator. So this is j12 over 4 plus j of 6. So I'm simplifying, or I'm working with this part here. So I'm going to multiply by the complex conjugate of the denominator, which is 4 minus j6. So times 4 minus j6 over 4 minus j6, so that we can remove that fraction that we have. Okay, so that is our z. So z was going to be 2 plus j5 minus, okay, let's simplify here. We can multiply the numerator. That's minus 4 to 4, which is negative 16, minus 4 and minus, that's a positive j24. 4 times 6, that's a 24. We move on to j12 and 4, that's 48. So it's going to be plus j48, plus j48. We move on to the j here, that's j12 and minus j6. Take note, we've got a negative and a positive, which is minus j squared. But we said j squared is minus 1. So it's minus and minus, which is a plus. So it was going to be plus 12 times 6, that's 72. If I'm not mistaken, that's a 72 there. Okay, in the denominator, we do the same. We have to multiply 4 and 4, that's 16. All right, 4 and negative 12, that is negative 6, that's negative 24. So it's negative j24. Then j6 and 4, that's a positive j24. Then we move on, positive and negative, that's a negative. So like what we did, then it's going to give us a positive at the end. So it goes going to be positive 6 times 6, which is 36. Okay, so this is what we're going to have at the end. Okay, so let's expand and see what you're going to have. Z is equal to 2 plus j5 minus the fraction. We are still having our fraction. We have to simplify further. Minus 16 plus 72. We can add these two. Minus 16 plus 72, negative 16 plus 72, which is 56. So this was going to be 56. 24 plus 48 on j and j, these are like terms, so we're going to add 24 and 48. 24 plus 48, which is 72, so it's plus j 72 over, as we can see, these two are the same, so this is going to cancel. On j24, minus j24 here and j24, this is going to give us a 0. So we are left with 16 plus 32. Okay, so let's add 16 plus 36, sorry, which is 52. So we've got 52 here. All right, so that was it. Then from there, we can actually expand everything, divide by 52. So it's 2 plus j of 5. So this can be divided 56 over 52. So let's divide 56, divide by 52. That's divide, okay, 56 divided by 52, which is something like 1.0769, which is 1.077. So you're going to have minus, okay, that's a minus 1.077. Okay, Then we do the same on 72. We divide everything. So this time is 72 and 52. Okay. 72 divided by 52. 72 divided by 52, which is 1,385. 1,385. So it's going to be plus 1, that's a J 1,385, like that. Okay, so that was it from this part. Therefore, you can expand the brackets by a minus. So Z was going to be 2 plus J5 minus times this, which is 1,077, minus times this, which is minus J 1,385. So therefore, we can collect like terms 2 minus, so it's 2 minus 1,0, whatever that we have there. Okay, so 2 minus 1,077. Okay, that's 0,923, 0,923, 0,923. 5 minus 1, whatever that we have there on J. Okay, so it's 5 minus 1,385, which was going to give us 3,615, but there's a J, 3,615 with a J. So that was the final answer. You are not told the format to leave your answer in, so you can actually leave your answer in this format. It was fine. Or you can leave in any other format of your choice, which is proper, but that is what we had. So as you can see, guys, this question, it had a lot. But these were the stages or steps that we're supposed to consider or to take. Okay, let's see. The other part on 5.4, we are now given to convert the following expression in polar form. Okay, but there, take note, this presentation here is for the determinant. Whenever you're given this presentation, is for the determinant, where we know that the determinant, we have to multiply the major, this is minus the minor, and also there we know that J squared is equal to -1. So this is same as we have got -1. Okay, so let's apply our determinant. So Z was going to be the product of J minus 1. So we've got J minus 1 into 2 plus J3. 2 plus J3 minus the minor diagonal, we've got -1. So it's -1 times 3 minus J4. So whatever that you're going to get there, then convert to polar form. So you're supposed to expand as usual, like what we're doing, J and 2, that's 2J. Then we've got J and 3. Take note, J squared is -1, so it's going to give us -3. -1 times 2, that's -2. -1 times J3, which is minus J3, okay? Then minus, we have to expand first, so it's minus times 3. This minus inside the bracket is the one that I'm using. So it's -1 times 3, which is -3. -1 times minus, which is a plus J4. Then from there, we can collect like terms, but before that, let's see, we have got like terms here. Z is equal to J2. All right, let's collect like terms. So we've got 2 minus 3. 2 minus 3, that's a -1. So this was going to give us negative J. -3, -2, that's -5. Expand the brackets here now by this negative. So it's negative times 3, which is +3. Then we move on to negative times positive, which is a negative. So it's negative J5, negative J4. That's a negative J4, if I'm not mistaken there. So that's actually negative J4, the one that we are given in this case. Take note, guys, of what we are given. This was 3 minus J4 or 3 plus J4. Okay, this is 3 minus J4. All right, so now let's collect our like terms. Let's see our like terms. Okay, everything is fine. This is going to be -5 plus 3, which is -2. Then we move on, -1, -4 on J, there is -5. So it was going to be negative J5. Okay, so this is our Z, but this Z is in rectangular form. This is a rectangular format that we have, or the Cartesian format. Remember, I talked about this. But the question is asking the answer to be in polar form. So we are supposed to convert back to polar form. So how now are we supposed to convert this in polar form? Remember, for you to convert in polar form, definitely you need the Argand diagram. Okay, so I'm just going to indicate it somewhere here. Remember, you need your Argand diagram where we have our real being negative, our imaginary being negative. So that's in the third quadrant. Real is negative, imaginary is negative. So this can happen in the third quadrant where this is our -2 and this is our -J5. Remember, in polar form, you're supposed to calculate the value of R and the angle that is affecting. So you're supposed to calculate this angle or to calculate this angle between the two. Okay, anyways, knowing that R is the resultant, so you can use Pythagoras theorem to calculate R. So R is simply the square root of A squared plus B squared, which is the square root of -2 squared plus -5 squared. So that was your R, which is the resultant. So negative, guys, is just the same. Because if you square a negative, it becomes a positive. So that one is just the same as the square root of 2 squared plus 5 squared. That's it, which is the square root of 29. So we're going to have square root of 29. Then we calculate alpha, which is the angle inside the triangle, the one that is going to help us to calculate the actual angle, which is our theta. So knowing that we've got, according to this, we've got opposite and the adjacent. So we're going to apply arctan. So alpha is equal to arctan opposite, which is 5/2. So it's actually -5 over -2, which is going to be arctan 5/2. So arctan shift tan 5/2, that's 5/2, like that, which is going to give us 68,12, something like that, which is 68,2. So let's just say for 68,2 degrees. This is our alpha, not the actual angle, but the one that is helping us to calculate the normal angle. So as we need this angle, which is from this point, so we're going to add 180 to find theta. So theta is going to be 180 plus 68,2, because this is where our 68,2 is located. So we add 68,2 from that one. So it's 180 plus 68,2, 180 plus 68,2, which is 248,2. So it's going to be 248,2, or you can use this other one here, which is 68,2 minus 180. So it can be like this, minus 180, like that, which is going to be -111,8, -111,8. So you choose which one of these to use. Mostly you're supposed to use the one that is less than 180, which is this angle, but you can even use this one, is fine. Remember that in polar form, your answer is supposed to be written as R cis theta. So Z is going to be R cis theta, or it can be R angle of theta, like that. So our Z was going to be R, which is square root of 29 cis theta. The theta now you choose between these two. Which one? I don't know. You're going to use -111,8, or you're going to use this one. Still, it's one and the same thing. Or you can write it as square root, that's square root of 29 angle of theta, which is 248,2. So you can use this angle or you can use cis. It's one and the same thing in polar form. But what was important was that you were supposed to calculate the determinant first using the determinant concept, then you convert your answer to polar form. That was the instruction, your answer to be in polar form. Okay, last question, simplify j to the exponent of 17. So how do I simplify j to the exponent of 17? We are supposed to write this in terms of j squared. So it's j squared. 17 is not an even number. So you target the number that is before 17, which is 16. So 2 to the exponent, j to the exponent of 2 to the exponent of 8. 2 times 8 is 16. So we've got 16, but we are left with 1j so that it can give us to the exponent of 17. J squared, knowing that j squared is -1. So it's -1 to the exponent of 8 times j, of which -1 to the exponent of any even number, it's a positive. So it's +1. So it's 1 times j, which is j. So j to the exponent of 17 is the same as j. So that's 1 mark, make a total of 20 marks, and a total of 100 in this question paper for Maths N4. So this was the question paper, guys, November 2022, Mathematics N4 from Maths on African Motives, working on engineering as we are revising towards the goal of making these things easier and available to us, guys, so that we can revise and also not only for revision, but to know about the exam so that you can prepare yourself either for the next level or to prepare yourself for the level that you're already doing. So it depends with what you saw from this part, but that's what we had for Maths on African Motives. Till we meet again.